So adding and subtracting polynomials. Recall, a monomial was a number, a variable, or a product of numbers and variables. We did a bunch of examples last class, so I'm going to say a polynomial was a monomial, or a binomial, or a trinomial. Find it? Were you just going to sit and hope I wouldn't notice? Here we go. Polynomial, binomial, trinomial. You know what? We know what that is. So, very quickly, we said, unless they say different, we write polynomials in descending order from highest degree to lowest degree. And I think I explained to you last day why, although we teach degree, Alex, out of context in this particular course in Math 10, it is actually important. It's useful in Math 11. Just not really here. Like terms. What are like terms? How are terms considered like terms in the mathematical sense? What was the definition, or what do they have to have? Ni. Same variable? So you're telling me that this and this are like terms? There's one more, same variables and same variables, same exponents. Same variables, same exponents. Example. So I'm going to make up a term. 5x squared y cubed z. And I'm going to put a minus sign right there just because. Make up your own like term. For it to be a like term, what must it have in it? Brody, what must it have in it? What did you say the definition was? So what is my variables and exponents? Read everything except the 5 out loud to me. What must it have in it? An x squared, a y, and no other letters. So put a number in front, just to be nerdy and different. I'm going to put a pi in front because that's a number. And x squared y cubed z. If you don't like the pi, you can put like a, I don't know, a 3. Those are like terms. The issue isn't what's in front. The issue is, Tyler, better have same variables and same exponents. If they are like terms, that means that you can combine them. You can do math with them. In fact, this would simplify to, what would this simplify to? What is 5x squared y cubed z minus 3x squared y cubed z? Ben?
2x squared y cubed z.
2x squared y cubed z's. And this is a tricky, by the way, the second definition is unlike terms. How about we just say not those things? Right? This is a tricky concept for kids to wrap their brain around. And the reason is, Ben, it's tough for me to point and say, look, there goes an x squared. Okay? It's tough. It says, to simplify polynomials, group together the like terms and add or subtract the coefficients. Next page, for example. Now, when we first introduced this to you in grade 8 or grade 9, Simi, we do this very, very systematically. We do this very, very carefully. And I'm okay if you still prefer to do that. But Garrett, I would love it if you can reach the point where you can do these mostly in your head. If you can, great. So here's what I mean. Probably when you're first taught to do this one here, A, your teacher probably taught you to rewrite the question and write all of the like terms in groups. And if you feel more comfortable doing it that way, okay, knock yourself out. And then probably your teacher taught you to go, well, Marcus, what is 3x take away 6x?
Negative 3x.
Negative 3x's. And what is 5a take away 3a?
2A.
Now, 2a is what I think, but out loud I always say to myself positive 2a in my head. And the reason I think positive 2a is, Marcus, what does it remind me to put right here? A plus 2a. If you want to do that much work, Darian, go ahead. Go ahead. I'm good with that. Here is my preferred method, and if you want to use this, feel free. Put your pencils down, look up. If they give me something and they say simplify and I'm gathering like terms, I want to find a method, Alex, that's organized and lazy. If I have to choose between lazy and organization, I'll choose organization. But if I can do both, why not? So here's Mr. Dueck's method. What I always do is I start with the first term. Alex, what's the first term? Just read it to me. And I decide, okay, I'm going to take care of all the x terms. I quickly underline them like that so they stand out. Takes 1 second. And then I can see it's 3x take away 6x. What is 3x take away 6x? And I would say to myself, self, that's negative 3x. And then what I do is I cross out those ones to remind myself that I've taken care of them. Then I move on to the next uncrossed out term, which in this case is a positive 5a. I underline all of the other a terms. I have positive 5a minus 3a, which is what? I cross out those terms. I double check, are any terms not crossed out? So I got them all? That's how I do it. Okay, that's even a bit of a fib. For something that's fairly straightforward, I'll do the whole thing in my head. And Amy, if you can't, like if you can do B in your head, great. If you can do C in your head, great. When they get complicated though, with lots of X's and Y's and Z's and all sorts of different exponents, I go to my underline the first one, find any others, cross out as you go, be extra uber careful method. So, having said that then, on your own, simplify B. Quietly, do it yourself. On your own means on your own. Write the answer down. Yes? Thumbs up, Sam? Yeah. I got 4x minus 3. C, you know what? 5 terms, I'll go with my underline cross-out method just to make sure I don't make a dumb mistake. Although in my homework, I'd probably try and do it in my head. Certainly on a test or a quiz, I would underline and cross out because I want to hedge my bets and make sure I get this okay. So try C on your own. I'll do it up here. Yes? I got 2x cubed plus 3x minus 8. Okay. So, to add or subtract polynomials, gather like terms. That's the fancy schmancy word for it. The most common mistake, kids want to do this. They want to do that. So when you're gathering like terms, when you're adding and subtracting, the exponents don't change, and those aren't like terms. Example 6. Okay, now we got some brackets here. In 6a, what's in front of this first bracket sitting right here? A positive 1. Is that really going to make a difference at all to what's inside the bracket? You know what? I can really ignore that bracket. What about the second bracket? What's in front of it? Also a positive 1. You know what? For all intents and purposes, even though they've added brackets in there, Anthony, to try and confuse me, that question to me is actually the same as 5a up here. I'm going to go 3x plus 2x and I'm going to go negative 5 plus positive 8. Actually, I'm not. I'm going to go 8 take away 5, because negative 5 plus positive 8 is the same as 8 take away 5. But I'm telling you, 8 minus 5 is way easier to do in my head. I told you there's a non-calculator section on your provincial. Did I? Yeah? Okay. Yeah? How is B a little bit different from A? Do the brackets matter in B? The second one, because that's not an invisible 1. What's in front here? Actually, a negative 1. Or you can just say, I need to distribute the negative. Really what we're doing is this, x minus 5 minus 3x minus 8. And now, Greg, I can gather like terms. X minus 3x, negative 2x. Yes, oh, yeah. Negative 5 minus 8. Subtract the 3, carry the naught. Negative 13. Again, if you're someone who has trouble with integers in your head, because you are going to have to do some in your head, see me after school. I'll happily do a little tutorial with you. Everyone has their own method of doing integers. I think of negatives as cold water and positives as hot water. And I imagine pouring stuff into jars. Go figure. C. Will those brackets make any difference? No, then gather like terms. Hey, I can be fancy. Ooh. There we go. Hey, what about in D? The brackets matter there. Yeah. All of them? I think the third one, the last one. Okay. Hey, let's see if without rewriting it we can just do it. Here's what I think to myself. I go 2x plus 5x minus 5x. What is 2x plus 3x minus 5x? 0x. Am I going to write 0x? Can I just write x instead? Oh, if I write x, what am I really saying? How many x's? 1. So no x's. Woohoo! Not going to write anything. And then I have positive 4 plus negative 2 minus positive 8. Or positive 4 take away 2 minus 8. 4 take away 2 is 2. Take away 8 more. Amy, would I do it that way on a test? No, I'd probably have rewritten this last bracket and done that, probably. Would I have done it that way in my homework? No, my homework, I probably would have tried to do it in my head like we did. So I want to get good at this. Next page. Figure it out. It's a little weird, I know. In some ways, adding polynomials vertically is a little easier if you keep things lined up. If I write them like this vertically, see, now I can kind of go, oh, my like terms are all in the same column. I got 4x squared plus 2x squared. Hey, Duick, that's 6x squared. It is. I got negative 5x plus negative 8x. What's that going to end up being? Negative 13x. And then I got a positive 9 plus positive 3. And the positive reminds me to put a plus sign there, positive 12. It's a little trickier with subtraction. I'm going to have to remember it's this minus this minus this minus this. For example, it's 5x squared take away or minus 7x squared. What is 5x squared minus 7x squared? Negative 2 x squareds. And here's the tricky one. Positive 4x minus 9x. Oh, wait a minute. What was a minus minus the same as? So you're saying this is really mathematically the same as 4x plus 9x? Oh, that's easier. What'd you say? What is 4x plus 9x? 13x, lucky number 13. And for the third one, I have negative 3 minus 8. What's a minus minus the same as? A plus? Oh, you're saying this is negative 3 plus 8, which Brody is fairly sure is what? Hey, he can get that on one hand. 5. Didn't need to take off his shoes. So there's some advantages to that method. I just don't like having to rewrite a question if they don't give it to me that way. I'm lazy. Organized, but lazy. Turn the page. I mentioned earlier, Brady, I mentioned earlier that some kids really find this difficult, and there's nothing wrong with that because this is very abstract. It's very difficult for me to say, look, there goes an x squared walking in the field. There goes a 3x down the hallway. What the heck is an x? What the heck is an x squared? What we're going to try and do is come up with a visual way, and some of you may find this useful. Now, I have to confess, full disclosure here, Amber, I am not a visual learner. I am an auditory learner. For me, would have found this and still find this somewhat tricky to wrap my brain around. Those of you that are artistic and like to draw, though, you may find this, oh, makes good sense. What? Put your pencil down. That's supposed to be a square. It's a terrible picture, so let's cheat. Actions, change shape to, woohoo, square. Does that look like a square? A little too skinny. Is that a square for you folks? See, on my screen, it's all distorted because the resolution on my screen isn't the same as the projector, but as long as it looks right for you guys, so that looks like a square. Oh, you know what? I'll prove it. I'll go like this. All four sides the same. Right? Here's my question. What if I told you that this was 3 long and this was 3 long? Centimeters, I don't care. 3. What's the area? 9? Or are you German saying no? 9? Yeah. How'd you get the 9? Length times width, or in this case, side times. Okay. Stay with me. What's the area? 16? What's the area if you didn't have a calculator handy? How would you calculate it? As an expression, what's the area? What would you do? How'd you get the 16? I heard it. No. It's 43 times 43, whatever that. How would you write that as an expression? I don't want the answer. I want the expression. Maybe it's too obvious. Wouldn't you do this? Amy, is that what you're thinking? Yeah? So, Amy, what if I told you, and you didn't have a calculator handy, what if I told you that this was 119 by 119? What's the area as an expression? 119 squared. Good. Now, ready? Here's the point. Amy, what if I told you this was x by x? What's the area? That's a picture of x squared. So I said to you, it's very difficult to say, hey, look, there goes an x squared. Actually, if this is x long by x long, that's a picture of x squared. Oh, what if we drew a rectangle? Again, that's terrible. Thank you, technology. What if I told you that this was 2 long and this was 9 long? What's the area? Knee. 18. Length times width? Good. What if I told you this was 20 long and this was 90 long? 1800. Length times width? Yes? What if I told you that this was 1 wide? And I also told you, I want the selection to, oh heck, lasso it, Mr. Duick, that the height of this guy was x, the same as that square next to it. What's the area? I heard it. 1 times x. Brody, that's a picture of an x. You want a picture of 3x? 1, 2, 3. Drawn more neatly than that with a rule, but there's a picture of 3x. You want a picture of 2x squared? There's a picture of 2x squared. And one of the things we're going to try and introduce to you today is a visual representation of polynomials. Some of you will be like, oh, this works great for me. Some of you will be, oh boy, okay, I'll memorize this, but you're really not convincing me that this is better. I'm in the second category, but then again, I learned math weird. I have a math degree. I liked math, which makes me in the small minority among adults. Okay? Pick up your pencil. Here's how we're going to somehow, here's our convention, here's how we are going to show this. First of all, if we color it in, that's going to be positive if it's shaded. If it's empty, and here's how I remember this, if there's nothing, it's negative. Nothing, it's negative. Nothing, it's negative. I can't think of a good way to remember that. Maybe I'll come up with something. I think empty, negative, nothing. Okay? So, here's a 1 because it's 1 by 1. That's the area. What would a negative 1 look like? Same size, but not shaded in. And try and draw your square better than me. Here's an x square right here. This bad boy. Because it's 1 across and x high, and you already said, oh, the area is x. Here's an x squared. How would I draw a negative x squared? Hollow, empty, nothing, negative. But a little neater than what I just drew. What this allows us to do, Alex, is to actually draw a picture of something fairly abstract. And in some ways, there are some uses to that. For example, I can say to you, hey, what is 1a a picture of? What is this? Positive or negative? Positive. Just always ask yourself that. Don't just go by it. X squared. Brody, say it louder. X squared. And 2 x's. That's what it looks like. Now, this isn't quite right. Technically, this and this should be the same height because they're both x long, but the graphics was not cooperating with me when I was making these on my word processor. What's B a drawing of? Yeah, Damien. X squared minus 2x. Okay. Next page. What's C a drawing of? Careful. Alex.
Negative 1x.
Ooh, nice. What? Wait a minute. I see a negative 2x and I see what happened? We're going to call this the zero principle. We're going to say, look, if you have a positive something and a negative something and they're the same somethings, add them up, that's a zero. It's a zero. That's really when you were doing equation solving last year and you were like adding 5 to both sides or subtracting 6 from both sides, you were utilizing the zero principle. You were saying, well, I want to get rid of something, I'll add its opposite. So say it again, Alex. You were on a roll. I cut you off. My bad. You said negative x. I agree.
Plus 4.
Plus 4. Now, so Alex, this is a picture of negative x plus 4, but it's not the simplest picture, which is why we say when you're gathering like terms, you're simplifying. You're cleaning up a picture. You probably never thought of it that way before, but you are. So D, what's this a picture of? Simplify it along the way. Let's see. Those guys cancel. I definitely see a 3x. Oh, and those guys cancel. 3x. 3x is the same as x squared minus x squared plus 3x plus 1 minus 1. But 3x is a much simpler way to write it. The other stuff is just clutter. E. What's that? Okay, let's go. Oh, by the way, do you see it's much easier or obvious that these are like terms and that these are like terms and that these are like terms because they're the same shape, which is clearer than same variable, same exponent. It's why some teachers really like teaching with this. I've never yet bought into it. I may. You guys are the first year that I'm using these with. We'll see how you like it. You're my guinea pigs. Again, I have to be careful because I'm not a visual learner. So, sorry, what did we say? 2x squareds, I agree. Positive, yeah. Oh, can I do this? Yep. So what are these two? Negative 2x's. Ta-da. Yep. It's funny, as I'm looking at faces, some of you probably more abstract, less artistic. I can see by your faces, your noses are wrinkled. You're hating this. And I can see 3 or 4 of you who are artistic, who are going, you mean I can draw math? Yeah. Now, example 2 says, use algebra tiles to determine the results of the addition. I gotta be honest. I find this easier to do, but then I've been doing this for, subtract the 3, carry the 43 years. Actually, okay, that assumes I was doing it when I was born. I've been doing this since grade 8, so 30 years. Some of you may find this picture more intuitive. I don't care which method you use. What I would like you to do, please, is either add that or add that. Simplify. Do it on your own. Yeah. The advantage with the pictures is, in terms of addition skills, the most you're doing is adding 1 or subtracting 1 with the 0 method. Yep. Someone had a question? You good? Figured it out? Am I wrong? Oh! I remember this. There is a typo here, and I fixed it in my last class. Can all of you write down make that there an X, because that's what the bottom picture is, and the top picture is wrong. Well, actually, one of them is wrong, and it's easier to change that than change the picture. Is that what you're going to say? Brody, my friend, you get a candy for spotting a mistake. Where I tend to draw the line, no pun intended, it says use algebra tiles. The amount of work for me to draw that from scratch versus the amount of work for me to gather like terms, did I say to you I'm lazy and organized? If they give me the picture, Tyler, I'm happy to go with the picture. If they want me to recreate the picture, I'm less enthusiastic. So you know what? Although it says use algebra tiles, I'm going to say, hey, gather like terms and simplify. Think. Thumbs up, Megan? Thumbs down? Oh, by the way, you might have wanted to do that. And if you did and you rewrote it, I'm totally good with that. Am I pushing you to try and do some of this? Sure. If this becomes boring and useless, then I've done my, like if this becomes, oh man, I can concentrate on other stuff and do this in my sleep, then I've done my job. What's it say next here? Complete class exercise what? Later. Okay. It says class exercise 3. Use algebra tiles to model each polynomial. Did I already tell you guys that drawing these is I'm not a big fan of? You do need to practice it a little bit. So I'm going to say for part of your homework, can you try 1A and 1D? Draw that, draw that.
Oh, Mr. George?
Yo.
Why are there two C's? The one that you circle is also a C.
Is it? I don't think it.
Oh, sorry. Just look weird from this angle.
Oh, on my screen it's faded. Look down on yours. Yeah.
Oh, okay. It just looks like a
Yeah.
C.
My projector's on its last legs. I put in for a new one.
Okay.
Yeah. I have this thing hot wired and cranked, and I'm getting as much as I can out of the bulb. But yesterday it was actually buzzing. I turned it off, and all of a sudden after 20 minutes, it just started sitting there buzzing. It's ticking away. You guys are close to it, by the way. Be afraid. So try drawing those, and then I think you can do all of number 2. Okay? Then you also, I attached class exercise 4, yes? I did, didn't I? Yeah. Okay. It says add or subtract the following with algebra tiles. Did they draw them for you, Garrett? In number 4 here on this page? Then you know what? I'm going to say, but I'm going to say, hey, try those. Yeah, all of number 3 questions, 3 whole questions. Whoa. And I got one more assignment I'm going to hand out, and then I think you folks can probably on Friday or Monday expect a quiz. The quiz will be on everything up to and including today. Okay? And you know what? Since I just did the algebra tiles for kind of like half the lesson, you can probably bank on none of that on the first quiz. Let me get you assignment number 2.